All right, let's take a look at today's lesson. So today we're going to look at volume one more time, but this time we're going to look at the washer method. And what I would like to do is pull up that little applet that we looked at last time. If you recall from last time, with this blue portion right here from A to B, this is the part that's going to be revolving around the axis of symmetry or axis of revolution. And so here, this is what we did last time. So we looked at it, and what we created, these were disks. And what happened, it was a disk because there's no hole inside here, right? It's just solid. So that is the disk method. What we're going to do today is we're going to look at what happens when the axis of revolution is not, basically the figure is not sitting on the axis of revolution. Let's say, for instance, that maybe the axis is down here at -2. So now what's going to happen when we rotate around the axis of revolution? So now I hope you can see we've got a hole in the middle of it. There's a hole, and so this is called washers. If you look at it, you've got the outside circle is like the big circle. We would call that radius capital R. And the inside circle is the smaller circle, and we would call that radius little r. And that's what we're going to be working on today, is how to set those up. So let's take a look at our notes. So what we do is we take big R of x, that's the outer radius, and little r of x is the inner radius. So if I were to draw, so let's just do a for instance. So let's say this is the figure that, this is a cross section, this is a disk. So if we look at this, we see that from the center to the outside, this would be like big R. Okay, that would be the big radius. If you think back to your days in geometry, when we were doing this in 2 dimensions, if we wanted to find the area of this shaded part, we would find the area of the big circle and we would subtract the area of the little circle, right? That's what we would do. And that's the same concept that we're working on, but with volume. So what we're going to do is our formula, if we are rotating about a horizontal axis, we would use x's. So our formula is pi integral a to b of big R of x squared minus little r of x squared. So that's different than last time's formula. Last time's formula, we just had pi r squared. We didn't have different circles or different radius. Okay, is everybody okay so far? Okay, so now if the axis that we're rotating about is a vertical axis, then we have to use y's. So this would be integral from c to d. Those would be our y bounds. And it would be r of y, big R of y squared, minus little r of y squared dy. And so these are very similar to last time's formulas. They just have that additional inside radius. And that's what we're going to be working with today. Okay? So we have, I don't know, I think maybe 5 questions, 5 examples to work through. So let's look at our very first one. And they nicely graphed it for us. I hope that we remember for these kinds of problems, volume and area, I need you to graph them. Okay, I need to see a graph. Sure. This part right here? Okay. You're welcome. We all good? Yes? Okay. So for here, they want us to find the volume if the region enclosed by the square root of x and x squared is rotated about the x-axis. Okay, so here we go. So this is my axis of rotation. I'm going to draw my little circle-y thing around it. I would like to kind of highlight the portion that I'm rotating. It's the portion trapped between square root of x and x squared. So this is the part that is going to be rotating. It's going to rotate like around like this, you know, over and over like that. It's going to rotate like that. Okay, so my job is going to be to figure out where my big R is and my little r. And let's just make ourselves a note. So this is a note. We always measure from the axis of rotation. Always. Okay, wherever it is. That's why I think it's kind of important for us to note it with this little circly thing. This is the axis of rotation. We're measuring from there. So from the axis of rotation to the far side of the figure. Okay, from the axis of rotation to the far side of the figure is big R. That is big R. Okay, and it doesn't matter where I draw that. It's just from the axis of rotation to the outside of the figure is big R. From the axis of rotation to the closest part, the underside of the figure, is little r. And before we can set up our integral, we need to figure out how to represent that. It's just big minus little. It's really big, just big minus little. Okay, so let's list out big R. So big R is, so big minus little. So this big one is, what is that? That's square root of x. And little is x equals 0. So it's really just square root of x. Little r, the big is going to be this parabola, which is what, x squared. And the little is, you know, y equals 0, which is 0. So when we're rotating about the x or y axis, our big R and little r are as simple as they can be. Okay, so now our job is going to be to set that all up. Okay, so here we go. So we've got pi integral. I could tell from this graph that it's 0 to 1, but if I couldn't, how would I find the intersections? I would set them equal to each other. I would say square root of x equals x squared, and I would solve. That's what I would do. But I can tell it's 0 and 1. So I've got big R squared, so that's square root of x squared minus little r squared, which is x squared squared. Now this one, actually this is the only one that we're going to do by hand. The rest of them we're either going to use a calculator or we're going to just write out the expression, the integral, and then stop. But we're going to do this one by hand. It's actually not too bad. So let's clean this up a bit. So this is pi integral 0 to 1. So the square root of x squared would just be x. And then x squared squared would be x to the 4th. Okay, so now we need our antiderivative. So let's put this, don't forget our pi. So the antiderivative of x would be 1/2 x squared. The antiderivative of x to the 4th would be, what, 1/5 x to the 5th. We're going to evaluate that from 0 to 1. Okay, so we've got pi. All right, so we put a 1 in, and I've got 1/2 minus 1/5. And then I put a 0 in, and I just have 0. Okay, so yes, I'm going to go ahead and I went ahead and found a common denominator that would be 10, right? So that would be what? That would be 5/10 minus 1, was that 2/10? And so that's 3/10, so 3 pi over 10 is my volume. And we don't have any units. If we did, then we could, you know, fill those in, but we don't have any, so we don't need to worry about that. How's our very first disk? Are we okay? Okay. I'll give you just a moment. Okay, so that's the only one we're going to calculate by hand. So let's look at our next one. So find the volume if the region enclosed by y equals x squared plus 1 and y equals 2x plus 1 is rotated about the y-axis. Okay, y-axis. Now that changes, basically changes everything, okay? When we're rotating about the y-axis, we have to have y's. We have x's. And that's like non-negotiable. We have to use y's. So I'm going to have to redo both of those equations to be x equal equations and not y equal equations. Okay, so you should make a note to yourself. This is a note. Vertical axes, we'll just say vertical, well, I'll just say vertical axis equals, I need x equals y's, not y equals x's. Okay, so, all right, well, we can do that. So I'm going to focus on this one first. So that I move the 1 over, I have y minus 1 equals x squared. I square root both sides. I get x equals plus or minus the square root of y minus 1. Okay, so let's think about that for a second. Plus or minus the square root of. So when x is positive, we're over here, right? That's where x is positive. So that's what we're going to need. We're going to need the x equals square root of y minus 1. Okay? When x is negative, we would be on this other side. Right? This would be when x is negative, and we don't even need that one. That's when x would be negative square root of y minus 1. Okay, so we don't need that one. Is everybody okay? We don't need it. All right, so we've got that figured out. Now we need to solve the line for x. Okay, so I'm going to move the 1 over again. Y minus 1 equals 2x. So x is going to be 1/2 times y minus 1. And you could distribute it out if you want to. I would probably just leave it like that. And so let's think about this. When we're doing big and little, when we have y's, remember, it's not top and bottom, is it? For x's, top is big and bottom is little, right? Big minus little is top and bottom. When we're doing y's, which direction do we go? Left and right, right? So for y, x equals a bunch of y's, the farthest right is the biggest one, right? And so this would be big, and this one would be little. This should be a review for you. We did that with area, and we've done it with the other lesson. So when we have y's, big is to the right, little is to the left. Okay, so let's set up. I'm going to look at this figure again. I'm going to highlight the part that we're rotating. This is the part that we're rotating. So we just know which way to go. So we have to measure from the axis of rotation. So from the axis of rotation to the outside of the figure, the very outside of the figure is big R. And from the axis of rotation to the inside, the closest part of the figure is little r. Okay? Big R and little r. All right, so let's write equations for that. So big R is going to be, we're going to go big minus little, right? Big is the square root of y minus 1, and little is 0. Okay, little r is, so we've got the little r, that's the line, so that's 1/2 y minus 1 minus 0. That's big R and little r. Is everybody okay with that? So what we're doing is we're noting that this axis right here, This y-axis is where x equals 0. Later, when we rotate around something that's not the axis, it's going to be a number. So I'm just getting us used to the number, that's all. So we're going from x equals square root of y minus 1 to 0, and x equals, 1/2 y minus 1 minus 0. Okay, so let's set it up now. So we've got pi integral. This one is a little harder to see, but I can still tell that where these locations are where those two intersect. Again, if I couldn't tell, I would set them equal to each other. My y value, my little y value is 0, and my big y value is 4. Wait, no, it's not that. This is down here. They're not showing the x-axis. The x-axis is right down here because my y-intercept right here is 1. So my little y is 1, 1, 2, 3, 4, 5, and my big Y is 5. Again, if I couldn't tell, I would set those equations equal to each other and solve. All right, so now I've got big R, which is the square root of y minus 1 squared, minus little r, which is 1/2 y minus 1 squared dy. Now, I would really put it in my calculator exactly like that. I wouldn't combine, I wouldn't do anything, but y'all can enter it however you want. I would do it exactly like that. And when you do that, you should get, as your final answer, is 8 pi over 3. Okay, how are we doing?
I'm a little confused how this is different from the other.
Different than what? The lesson from last time?
Mm-hmm.
The lesson from last time, there was just R. There was just R. There was no big R and little r. So notice how from last time, see how this pink part is sitting on the axis of rotation? It's just flush sitting on it. Right here, it's sitting on this axis of rotation. This is a disk. This just requires, sitting on the axis of rotation, sitting on the axis. That just requires R. Today's lesson, notice that here, this tip is sitting on the axis of rotation, but that's not enough to be a disk. That whole thing would have to sit here for that to be a disk, and it's not. So when this rotates around and around, okay, there's going to be this empty spot right in here that we have to subtract out, because this pink part is going to be solid as it moves around the axis of rotation, but it's going to leave a hole in the middle, which is why we need a washer and not a disk.
Okay.
Does that make sense?
Yeah.
Okay. All right, let's look at this one. So we want to find the volume at the region enclosed by, okay, and then let's just kind of highlight, let's put that region right here. This is the region. They nicely graphed it for us already. Square root of x and y equals x squared is rotated about the line y equals 2. Set up but do not solve. Okay, so let's put our this is our axis of rotation. Y equals 2. Okay. Now, remember, we're measuring from the axis of rotation. So let's make this a bit bigger. So I go from here all the way to the far side of the figure. That is big R. And then I go from here to the closest side of the figure. That's little r. Okay, so let's write down our equations over here. So what is that? Square root of x, that's the square root of x, and that's x squared. Okay, so let's write our big R. It's going to be big minus little, right? And this is a horizontal axis, so it's going to be the top one minus the bottom one. So big R is going to be 2 minus x squared. Okay, so I'm going to pause there for a second and make sure we're okay. Big was 2, so this is y equals 2, and this is y equals square root of x, and y equals x squared. That's what those are. So I go from 2 to x squared for the biggest radius. The little one is going to be what? 2 minus square root of x. Yeah, that's the little one. 2 minus square root of x. So this one's a little bit more complicated because we're not rotating around an axis, the x or y axis. This is where it gets just a little bit more intense. But if you just remember big minus little, you will be fine. So now let's set, this one is just a setup. We don't have to actually put it in our calculator. So here we go. So I've got pi integral, and this is 0 to 1 of big R squared, which is 2 minus x squared squared, minus little r squared, which is 2 minus the square root of x squared dx. And that's all they want us to do is set it up. And we're done. Again, if we put, it wouldn't be a big deal to put it in our calculator. I'd put it in exactly looking just like that. Okay, we doing okay? We have just one more to do. Are you ready for the last one? Yes? Okay, let's look at our very last one. So we want to find the volume of the region enclosed by, so we've got a parabola, x squared plus 1, and we've got a line, 2x plus 1, is rotated about the x equals negative 1. Okay, so let's write out, first of all, let's highlight, this is the part where, this is the part we're rotating. Okay, so we're going to rotate that. We're going to rotate that about x equals negative 1, which is right here. Okay. This is a vertical axis. What do my equations need to be? Do they need to be x's, x equals a bunch of y's, or y equals a bunch of x's? X equals a bunch of y's. This is the kind that is some of ours not our favorite. Okay, so let's list out first. So big R is going to be from the axis of rotation to the far side of the figure. That's big R. And little r is going to be from the axis of rotation to the inside of the figure. Notice how I'm measuring from the axis of rotation. Always. Okay. So, remember, big is this way when we're doing x equals y's. Now, again, it's not in, these are actually, I don't know if you remember, these are the same equations from the problem above. I don't know if you remember that, where we solved these. So I'm just going to go straight to the solving. So for the parabola, we got it as x equals plus or minus the square root of y minus 1. And for the line, we got it as x equals 1/2 times y minus 1. Okay, those were the equations. When we solved for x, that's what we got. Okay, so let's list those over here just so we have them. So let's see, this one is x equals the square root of y minus 1. And that line right there is x equals 1/2 y minus 1. And then this is x equals negative 1. Okay, we ready for our big R and little r? All right, so we've got big R equals, so we've got this biggest one, so the farthest right is that square root of y minus 1 minus the farthest left is negative 1. That's my big R. Okay. Little r is the farthest right is the line 1/2 y minus 1 minus the farthest left is -1. And that's my big R and my little r. Okay. So this is another one where they just wants to set up and don't put in our calculator. So pi integral, our y bounds, the smallest y is 1 and the biggest one is 5. R, big R, is the square root of y minus 1. And I probably would, a minus 1 means plus 1, so I probably would just go ahead and do that. Minus. Okay, little r is 1/2 y minus 1. Minus a minus 1 would be plus 1 squared dy. And I would totally put it in my calculator exactly how it looks with the parentheses and everything. Although we don't need to, they told us we didn't set up but do not evaluate. So that's our final answer. Okay, how are we doing?